Good morning to all. In this today's class, we are going to see about the ninth lesson, and the continuation topic is determination of charge of an electron, Milligan's oil drop experiment. So in this experiment, we have to determine the fundamental constant of nature, that is known as charge of an electron. So now this is the another method of finding the charge of the electron. So previously we are finding one more method, that is the determination of specific charge. So with the cathode rays, so that is uniform electric field and also constant uniform magnetic field, like that, without the field. So we are found that. So now we have to find this charge of an electron with the help of the Milligan's oil drop experiment. So this is the apparatus which are going to find out the charge of an electron. So in this process, the non-viscous liquid can be sprayed through the small hole using the atomizer, and it can be passes through between the two metal plates. So in between that, the drops between two plates A and B, or it can be maintained as some field, that is electric field, and the drops can be moved from up and down by adjusting the field, and it can be clearly, we have seen see the telescope. So because of this method, we are going to find out the charge of electron here, that is charge of electron here. And this is the apparatus arrangement of this Milligan's oil drop method. In this arrangement, so there is small hole at the top of this instrument, and in between that there are two horizontal metallic plates A and B. So its diameter 20 centimeter, and it can be placed about 1.5 centimeter. So like this it can be arranged, and it can be maintained by the potential difference of around 10 kilowatt. So and that the electric field acts vertically downwards direction, and also the atomizer is kept exactly above the hole that can be using to spray the liquid. The liquid is viscous non-volatile liquid, so that can be sprayed. So that liquid can be fall freely downward direction, so under the influence of gravity. So a few drops in the chamber can acquire the electric field, so because of the friction of the air and also the X-rays in between the two plates. So the light can be used because we are able to clearly see the drops. So that can be seen clearly using the microscope that is also placed perpendicular to the light beam. So in this method, these drops can move upward direction or downward direction. It can be maintained using the electric fields between them. Let's see that parameters, that is m is the mass of the oil drop and it can be charged. This force can be there are some of the forces can be acted on the droplets, so that are all gravitational force, electric force, and the buoyant force. So you know that buoyant force, so against that drop up and down it can be using that, and also the viscous force. So these are all the force acts on this droplets. Let's see the determination of radius of the droplet here. Let's see this. So here the gravitational force Fg is, it can be acts downward direction, and also the electric field Fe is also maintained in the upward direction, that is equal to QE, and the gravitational force is maintained at F is equal to mg, and the buoyant force that can be acts upward direction, that is Fb, and the viscous force, it can also acts in the upward direction. So there are three forces can be act on the upward direction, and only one force can be acts on the downward direction, that is Fg. In this diagram, this free body diagram of the oil, which can be shows the two figures, that is A and B. So first one is denoted as the without electric field. So in this without electric field, it acts to upward direction, that is the two forces can act upward direction, and one force acts as a downward direction. And the second picture, that is a B drop, represents the with electric field. So in this electric field, there are two forces acting on upward direction, and only one force can be acts in the downward direction. So let's find out the determination of radius of the droplet first. In this derivation, first we are find out the first picture free body diagram. So there are two forces acting on that. Fg is equal to, that is three forces. Fg is equal to Fb plus Fv. So what is meant by Fb? Buoyant force, and also Fv, viscous force. So that is equal to the downward force because of this force balancing equation. Downward force is Fg. So now let's substitute all the F values and find out the values of radius of the droplet here. So first Fg. So what is meant by Fg? F is equal to mg, isn't it? F is equal to mg, so that is the gravitational force. So now let's find out the m value with the help of the density value. So you know that density rho is equal to mass by volume. So because of that we have to find out the mass value, that is m is equal to rho into v. So V value, so here the sphere can be used. The volume of the sphere can be denoted as 4 by 3 pi r cube. So substitute that value and finally you get the m value. So m is equal to rho into 4 by 3 pi r cube. Now substitute the value of m value in Fg. So mg is equal to rho 4 by 3 pi r cube into g. So here, and also the upward thrust is also the equal amount, and we have to change only the density of the upward value. So display, that is the density of the air. So here Fb is equal to sigma 4 by 3 pi r cube into g, that is the upward thrust force value, and also substitute these values in, and also the viscous force value is equal to the Stokes law. So according to the Stokes law, the viscous force value Fv is equal to 6 pi or V eta. So this is the value. Substitute in equation, that is the balanced equation. Now we equate all the values in the balancing equation, that is Fg is equal to Fp plus Fv. So substitute all the values and we will now find out the values of radius of the droplet. So that's why, so R can be, we have to find out and rearrange all the values and simplify that above equation. Then finally rearrange R values in one side and other values in other side. So R is equal to 9 eta V divided by 2 into rho minus sigma into G, that is the whole power 1 by 2, that is a root value. So this is the radius of the oil drop. And next we have to find out the determination of electric charge here. So now we have to apply the electric field and find out the electric charge value. So according to that, applying electric field, Fe, that is Fg is equal to Fe plus Fv. Fe is the electric force value, that is electric field force value, that is equal to Qe plus buoyant force, you know that 4 by 3 pi r cube sigma g is equal to gravitational force value 4 by 3 pi r cube rho g. So finally you will find out the value of charge, that is Q is equal to this value, and substitute the value of R value, that is already we are found that R value, and substitute in this equation. Then finally you will get Q is equal to 8 pi by E, that is in the whole, that is square root of eta cube V cube divided by 2 into rho minus sigma into G. So this is the value, and substitute all the constant values, and finally you will get the value of charge, that is minus 1.6 into 10 to the power minus 19 coulomb. So in this method, so the Milligans repeated this experiment several times and find out the charges on oil drops method. So this is the one of the method we will find out the charge of an electron. The next topic is Rutherford atom model. So in this atom model there are two topics out there, Rutherford atom model and also Bohr's atom model. The first one is Rutherford atom model, and it is also called as scattering of alpha particle. So in this atom model, this diagram shows a explanation of the scattering of the alpha particles that can be explained by Rutherford. So here the lead box is present. So in this, inside the lead box there is one of the, that is the radioactive substance, one of the radioactive substance, polonium sample is present. So in this polonium sample, the radioactive rays can be passes through a fine hole, and it can be passes through the lead screen. So this lead screen able to pass through in a straight line, this alpha rays can be passed through in the gold foil. So this gold foils, it can be, after this it can be scattered in a many angles that can be catched by a, that is, fluorescent screen. So zinc sulfate fluorescent screen, so it can be shows a flash of light on that. So we have to observe through the microscope. So this is the experiment called the scattering of alpha particles. So in this experiment, Rutherford proposed an atom model, that is the results of alpha scattering experiments. So in this experiment, alpha particles were allowed to fall on the atoms, that is the metallic gold fossils. This result is most of the alpha particles were undeflected through the gold fossils. It can be written, that is written to that, and also some of the undeflected gold fossils are went straight line. Some of the alpha particles were deflected through a small angle, and few particles also deflected through a more angle, that is more than 90 degree. So this is the observation of this experiment. And also few alpha particles returned back, that is deflected back by 180 degree. So these are all the observation of this Rutherford atom model. Conclusion of this atom model based on this observation means, so the nucleus is, that is, the Rutherford proposed the atom has a lot of empty space. So expected there is a lot of inner electrons are present in this, but he observed there is a lot of empty space inside the atom. So it also contains a tiny matter that is present at the center, that is called the nucleus. The size of the nucleus is 10 to the power minus 14 meter. So the nucleus is also the positively charged, because the undeflected and also returned scatter is also happened. So the nucleus is surrounded by a negatively charged electrons. So this static charge distribution cannot be a stable equilibrium. So it can be suggested that the electrons are not in a rest position, it always revolving around the nucleus, that is in the circular orbit. So like a planet revolving around the sun, like that the nucleus can be revolving around the electrons. So next he found that distance of the closest approach. So this is the closest approach, the distance of the closest approach. This is one of the distance, that is the minimum distance between the center of the nucleus and also the alpha particle. So this alpha particles, it gets reflected back through the 180 degree, that is defined as the distance of the closest approach here. So how can we find out this closest approach means that all the kinetic energy of the alpha particles is converted into electrostatic potential energy here, because the kinetic energy can be converted into potential energy. So we have to equate the two values, kinetic energy and potential energy. So kinetic energy half mv square is equal to potential energy that already we studied in the first lesson. So there are two charges. The potential energy between the two charges is 1 by 4 pi epsilon naught q1 q2 by r. So that is q1 q2. q1 is the one charge and q2 is the another charge, here 2e and also ze. So that can be, we found out that is the minimum distance, that is closest approach means r0. So you have to find out the r0 value, and all the values can be taken in another side. So finally r0 is equal to 1 by 4 pi epsilon naught 2 z e square by ek. So this is the value of the closest approach. And next one is impact parameter. In this impact parameter means it is also the perpendicular distance between the center of the gold nucleus and also the direction of the velocity of alpha particles. So it is a large distance. It is also a large distance. It can be calculated by, so the distance between the center and also the nucleus is b. So this b can be directly proportional to the cot theta by 2. So here, so this is the value of impact parameter. B is directly proportional to cot theta by 2. B is equal to k k, that is introduce one of the constant, so k cot theta by 2. So k is a constant value 1 by 4 pi epsilon naught 2 z, so e square by m v square. So here the theta is called the scattering angle. So this implies the impact parameter increases, the scattering angle is also decreases. So smaller impact parameter will produce a larger will be the deflection of alpha particles. So this is the impact parameter. And what are the drawbacks of Rutherford model? So Rutherford atom model that can be help to find out the calculation of the diameter of the nucleus only, and also we have to find out the size of the atom. So but it has some of the limitations of this, that is a drawbacks, that is also a disadvantage. So the first one is this model fails to explain the distribution of electrons around the nucleus. So and also the stability of the atoms. So the electrons can be revolving around the nucleus means, so this accelerated charge should emit the electromagnetic radiation continuously, but so due to this emission of this radiation, the charge loses its energy. So he does not explain because of in sustain in the circular motion the radius of the orbit, and also it becomes smaller and smaller, and it go finally the electron should fall in the nucleus. So but that cannot be happen in this atom, so because it always revolving around the nucleus. But here he does not explain the stability of the atom also. So according to this model, emission of radiations must be continuous and give continuous emission spectrum, but experimentally we observe only the line spectrum. So that is also, so these are all the drawbacks that can be not explained by the Rutherford atom model.